Okay, this video tutorial looks at the mathematical strand of probability, and more specifically we're going to focus our understanding on using two-dimensional grids and tree diagrams. Okay, the first thing we are going to look at is using two-dimensional grids to solve probability questions. So sometimes you're going to be asked to determine a sample space, which is basically every possible outcome of an event. And if that sample space is too large, then we can use what we call a 2D grid. Now, a 2D grid looks like this, where you have one outcome on the y-axis and one outcome on the x-axis, and in the middle are all the possible options. So as an example, if we wanted to draw a grid of the scenario where two coins are flipped simultaneously, so that means at the same time, in coin 1 we have our options of heads and tails, and if coin 2, we also have heads and tails. So therefore, we can say that our options are tails and tails, heads and tails, tails and heads, or heads and heads. Because when we go up, we can see along here and along here gives us a head and a head. If we keep going further, this gives us a tail and a head, and the same thing, head and a tail, a tail and a tail. So we can see that the 2D grid is able to be used to identify all of the possible outcomes. And it just says, draw a grid, we've done it. So we can actually see here that the possibility of getting a tail and a tail is actually 1 in 4. Now, this scenario has quite a small sample space, but we're going to look at an example that has quite a large sample space in a minute. Obviously, a head and a head is 1 in 4. Now, if we're looking at either a tail or a head, we can find out that this is going to be 2 out of 4, or if we cancel down, 1/2. Here is an example where we're using a 2D grid where the sample space is quite large. Okay, in this particular case, we've got 36 different possibilities where we're rolling two normal-sided, six-sided dice, and we're looking at the different outcomes. So if we want to use our 2D grid, which we've got here, to help us determine A, which is 2 3s, we're looking at if we roll a 3 on dice 1, okay, here's the 3, so we're rolling a 3 on dice 2, that means that this dot here is going to be 3 and 3, all right, and that's going to be one option out of our total 36 that we've got on our 2D grid. If we're looking at our part B question, it says a 1 or a 2. Okay, so we've got a 1 or a 2. We know that these dots all have a 1 because that's a 1 on our dice 1. We've got a 1 or a 2, so all of these could have a 2 on our dice 1. But we're actually also looking at all of these possibilities because it didn't specify which dice had to have the 1 or the 2. Now, if we look at all those, that gives us a total of 20 out of 36. We can cancel that down to 10 out of 18. We can cancel that down again to 5 out of 9. So the probability of rolling a 1 or a 2 is actually 5 out of 9. For our last question, it says the sum of the two dice is greater than 5. We now need to identify which ones would be greater than 5. Well, everything along here would be greater than 5. Everything along here would be greater than 5. If we roll a 4 on dice 1, we need to roll a 2 on dice 2 or above. If we roll a 3 on dice 1, we need to roll a 3 on dice 2 or above. If we roll a 2 on dice 1, we need to roll a 4 or above. And if we roll a 1 on dice 1, we need to do a 5 or above. So we simply now count all the blue dots, and that'll be out of 36, and that'll give us our probability. Gives us a total of 26 out of 36, or 13 out of 18. Okay, so sometimes when we're looking at problems with probability, we may be asked to draw a tree diagram. And a tree diagram basically allows us to write the path of particular events happening or not happening. Okay, so we're going to have a look at an example here. First example is Callum is having computer problems, and his tablet will only turn on 90% of the time, while his laptop will only turn on 70% of the time. The first thing we need to do is work out what's the probability that both will turn on when he goes to turn them on. First thing I'm going to do, the tablet on or off. There is a 90% chance, so 0.9% chance the tablet turns on, which means there's a 0.1%, or 0.1 probability that it doesn't turn on, so it stays off. Once he's determined that, the computer, okay, or his laptop, then has a 0.7 probability of turning on and a 0.3 probability of turning off. So I've just turned my percentages into decimals. Whether the tablet turns on or off is irrelevant because the same probability for the computer or the laptop stays the same. 0.7, 0.3. Now, we need to make sure that whichever path we take, we actually multiply the branches. So, for A, if they both turn on, we know that we're following this green path, on and on. So that would be 0.9 times 0.7. 0.9 times 0.7, 0.63. Okay, so the probability of it turning on and on is 0.63, or 63% of the time. For our second question, it says his laptop turns on, but his tablet doesn't. So the tablet is off, but the laptop is on. So we have 0.1 multiplied by 0.7, which is equal to 0.07, or 7% of the time. Okay, let's have a look at another example where we need to use a tree diagram. It says bag A contains 4 red beans and 1 yellow bean, while bag B contains 2 red beans and 3 yellow beans. A bag is randomly selected using a coin, and 1 bean is removed. Determine the probability that the bean is red. So, first thing we're going to do, we're going to have to flip a coin. The coin will be sided A and B. Okay, and we know that we have a half, or if we want to keep it as, oh no, I'll go fractions because I went decimals last time, so I'll go fractions. You can use either, it doesn't really matter. And then we have bag A can either give us a red bean or a yellow bean, and bag B can either give us a red bean or a yellow bean. Now the fraction of getting a red bean in bag A is 4 out of 5. That means that it's 1 out of 5 for a yellow, and in bag B it's 2 out of 5, and getting a yellow is 3 out of 5. So in this particular case, we need to work out the chance of getting a red bean in bag A. That's going to be this green line and that green line. So we're going to have 1/2 times by 4/5, in bag A. But we can also get something from bag B. If we follow the line in bag B, we go this way and this way, which gives us 1/2 times 2/5. Now we need to add them together because we don't know, we've got the option of going bag A or bag B. So we work out what that equals. Well, in this particular case, we've got 4/10 plus 2/10. That's going to give us an answer of 6/10 or 3/5. Okay, based on the information that we've gone through in this video tutorial, here are some practice questions that I would like you to have a go at. Please feel free to pause the video, have a go at them. When you think you've got the correct answers, continue the video and we'll see how you went. For question 1, it said, using the 2 spinners, determine, using a 2D grid, the probability of spinning a 1 and a 2. Okay, so if we're going to draw our grid, we have the blue spinner, and we have, don't know what color that is, I'll call it orange, even though it may not be orange. Orange spinner. Our options on the blue spinner are 1, 2, 3, 4, and 5. Our options on the orange spinner are 1, 2, and 3. Therefore, we're going to have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 total outcomes for this particular event. And it says the probability of spinning a 1 and a 2. Okay. Now, if we're going to spin a 1 and a 2, it doesn't say which spinner has to be a 1 or has to be a 2. This dot here will give us a 1 and a 2. And this dot here will give us a 1 and a 2. So therefore, the probability is going to be 2 out of a total of 15. Okay, so in our second question, it says you are asked to choose one bean from bag A and then follow by choosing one bean from bag B. Using a tree diagram, calculate the probability of choosing one yellow bean and one red bean. So our first option is bag A. And in bag A, we have red or yellow. We have 4/5 chance of choosing a red and 1/5 chance of choosing a yellow. Once we've done that, so this is bag A, we then have to choose from bag B. And we can either choose a red or a yellow. So we have 2/5 chance in bag B of a red and 3/5 chance of choosing a yellow. And it's the same for our other option. Now, we can either take the first route where we choose one red from bag A, followed by one yellow. So we have 4/5 times by 3/5. Or we can follow a yellow from bag A, but then we would have to choose a red from bag B, which would be 1/5 times by 2/5. This would give us 12 over 25 plus 2 over 25, which would give us a total of 14 out of 25 as our probability.